Okay, it looks like we are live. So welcome back. Today I'm going to be continuing to work on my virtual machine. So I'll just put the link in chat. So let's take a look at what we've got so far. So if I build, and actually we can build all the tests as well. I did fix that so it worked now properly. Yeah, so now we have the test. So let's run one of these. So let's look at hello-world.test. .tim actually. Hello world. There we go. So let's look at how that works. TASM. So we import the standard defs, which is where the standard out macro is defined. So basically, we push this string, and then we print it out. And this is the length of the string. This is the file descriptor, and obviously this is the syscall. So I'm planning on changing quite a bit of stuff today. First of all, this I'm going to change this. So we are going to have where you push the length, and then you push the file descriptor, and then you just call write. Yeah, so you just call write like this, and it will take those two things from the stack. Well, perhaps actually, maybe it would be better like that, where you push the length, and then you write to, just like that. So that is more what I want to do. That should be fairly easy to fix, because I think that works better, because we're actually utilizing the stack, and then we don't have to have this. Let's see. So yeah, in here we have size t length. I'm just going to get rid of that entirely. So first let's go into the .c file, and where we have write, basically, so length is going to be popped off the stack. So int length equals pop machine. Yeah. So the string is that. So actually we have to pop this first. And then, yeah, so stack size minus equals that. Yeah, so that's all good. And then here, yeah, so, yeah, instead of this, we just want length in there. And then we do have to handle it in the actual assembly. So that should be fairly easy. So I don't think we have to change the lexer at all, but we do need to modify the parser. We do actually have to, no, we don't. All right, yeah, the parser. Quite important that we modify that. So basically we have right here. Yeah, and we check the next one's int. We just need to check if the one immediately after it is int. So I think we can just do, well, no, because that has label as well. So yeah, so we will just, I should make like a function for checking. I can do that now. But yeah, so basically we can just get rid of this one entirely. Yeah, so that should pretty much be all that we have to do in here. Now we just have to modify it in the actual assembler. So in the right, where do we have right? Yeah, right here. So this, we can get rid of that. And let's see, I think that's it. It is not quite. So that is in tim.c. Yeah, so that dot length. So that is 286G. So that's pretty easy. We just need to change this to be length instead of dot length. As well as up here, this can be, yeah, just like that. Let's see now. Yeah, so where is that at? This needs to be as in. And there we go. So now let's try running it. Test/hello-world.tasm. Yeah, so I need to do it like this. Hello-world.tasm. Hello-world.tim. And there we go. It works now, and I think it's a bit better syntax. Because we're actually utilizing the stack. So let's make sure. Yeah, so this is how it works now. So you write, and then you put the file descriptor. So you could do standard error. I don't think there's really a way to check that, but yeah, but you can see there that all works. Yeah, so now I'm pretty much just gonna remove this entirely. Yeah, so basically we need a way to interact with the operating system. Right, so calling syscalls and stuff. So we can do that through native C functions. So if we had something like native 1, right, that could be right. So rather than write, you would type out native1. And basically that would function the exact same way. So if I actually go into here, I'm going to add a new one, a new thing here. So where do I have, I'll put it for right, and I'll call it native. So the naming at least is coming directly from Zoding's, can't pronounce words, coming from his BM implementation. I don't remember how it's implemented, but the name, calling it native with a number associated, that is from there. So yeah. And I actually haven't added any of these things here, but that's okay because I don't really use it. So yeah, so basically we have that now, and we do need to modify a couple of places. So down here, yeah, so it goes right here, so I can yank that. Inst native, and we are going to do some stuff. Not anything yet. So, yeah, let's actually modify the Lexer. Yeah. In here, we need to add native. And I just messed that up a lot, but I think it's right now. So then, fairly simple here, we need to handle that in here. Okay, and then let's see, and in here, this is where it's actually, so right here, we can just basically do that, and I could actually make this look a lot nicer. Yeah, basically, by moving it all into one line, that would probably look a lot better. Yeah, so actually this needs to be type native. And then I think that's all that we have to do in here. So that should be good now. And now let's go into parser.c. So it's going to be handled the same way as this. So type native. So we can just completely remove the right. And that's okay. So that's basically what we need to do there. Because we're not going to be using right anymore. I'll still have it in there. We do need to change this actually up here. Actually, no, that's in the Kazan.c. In here, we need to add inst native. So yeah, so we have that. And then here, this can just be changed to type native because it will functions more or less the same way because we have the identifier or the keyword and then the number immediately after it. So then it is going to be done differently in the virtual machine itself, obviously. But I think if we build that, let's see. So we don't have any problems. So let's make a test.test, no, test.tabby. And yeah, so we'll just push 15. Actually, no, we don't need to push anything. We'll just do native full, right? And then build it again. Test.tasm, test.tim, and it should say not implemented yet. Alright, so that is good. It looks like we are working properly. So, yeah, basically in here, what we're going to do is we are going to have, well, we'll basically have another switch statement. I think you're allowed to nest switch statements. So basically, we will do machine instructions IP dot value dot as in. So case of 0, case of 1, case of 2, something like that. So we can break, and here we'll do a default, which can just be assert. Well, we can actually print an error here. Error, unexpected native, essentially is what that is, and then exit 1. Yeah, so then we can deal with that. So basically, case 0 will just print f case of 0, and just to make sure it works. So let me open the test.tasm, and we'll push, or we'll not push, we'll do native 0, and we'll build this, and I forgot, semicolon. Alright, so now, test.tasm, test.tim, in case of 0. Alright, so that is good. So basically, well, so 1 at least is going to correspond to right. So we'll do native right is what we'll call it, and we'll just pass the machine as well as the IP. And I think that's all that we need for there. So basically, we'll implement this as a native one, and then we'll be able to easily implement different functions, which essentially act as instructions. And this will be where basically any syscall kind of things would be done. So we can have read, write. We'll have malloc and stuff like that in here as well. Yeah. So basically, native write. So this can basically just go into the native write. So if I just yank that, and then up here, so we'll define the native ones. Those can go at the top, actually. I think that is fine. So native functions. So native write, and then yeah, I'll paste this in here. So yeah, we need the machine. That, and then we also need the int IP. And it should probably be a pointer. So we will have to dereference it here, but are we going to iterate it actually? We don't iterate it here, so we don't need that as a pointer. Value. Alright, and I think that is all that we need to do, just about. So, assuming everything is right, we build this. It is not right, okay. Get served from stack. Okay. Oh, because we actually, yeah. So we actually need to define that in the header file. So if we go back here, we have this. We just need to put it in here. So what's the order actually? It's right before print stack. Yeah. So now it should work. Alright, so we do have some other problems. Native right. So we need to return from this actually. Yeah, we'll just return 0. Yeah. So it could be a void probably. Maybe I'll just make it a void. Yes. Okay. So let me actually modify this to be 1. So basically, it's going to function the same way. So we can push hello world. We don't need that. And then we'll push, yeah, so actually we do need to get it from the stack. So I do need to change some stuff. So, yeah, so it's fine for now because I'm going to change it. Yeah, so push 14, and so it will work like this. But yeah, so we'll run tasm, s.tasm, s.tim, and hello world. So it works. So that is right. And something we can do is we can have a macro, which is just called write, which expands to -1, and then we can still do write here. So let me go through the code and remove any instances of write. So tasm.lexer.c. So and as well as lexer.h. So we can get rid of write right there. And we actually need to remove that from here as well. So write, get rid of that. Get rid of it down here. So that is that. And then in here, just anywhere that we have write. So we can get rid of that. And that. And I think that's all that we have in there. So now we can open the parser now. C and parser.h. Yeah, we don't need to actually do anything in the header file. But down here, we already got rid of it actually in the rest of them. So, alright, so it doesn't work. Oh yeah, because I need to change it in the tasm.c because I still have this in here. So now, there we go. And so we run tasm, s.tasm. So that didn't work. Okay, is it because of that? Well, that's not gonna work now, but unclear label. So is there a problem with the preprocessor? There is. Okay, so that's not good. Well, you know what it is actually? Right. So then just make this right. Yeah, so there we go. So that I think is what the problem was actually. Because I had the extra integer after. So Hello world. Okay. Yeah, so now we can just we can add this to the standard defs, and then you'll be able to use write like that. But we need to also push standard out like that. So we do need to basically change it again, yet again. I think that is just in here though. So yeah, we can just change it in here. So we can basically we have to do it first. File descriptor equals pop machine by as yeah, and then so then this can be just file descriptor, and I think that might be all that we need to do. Descriptor and build, and it doesn't work. Unused parameter IP. So we don't use that anywhere. So we don't even need it. Okay. Alright, TASM, test.TASM. Type of label. Oh, no. Oh yeah, because we don't actually have that here. So I can just make this 1. So now if we run that, test.TASM, test.10, hello world. And yeah, we can change it, obviously, to whatever. This might be an error. I'm not sure what happens if you put the wrong one. It just doesn't output. Alright, so that's cool. Right? So now we have native functions. So I can actually update the hello world. So let me just remove test.tasm, remove test.10, and I'll exit out of here. So let's go into test and then hello world.tasm. And yeah, so basically, so we'll just do write, and we'll push standard out, something like that. And then standard defs, we can add def, alright, write is native 1. So then, hello world.tasm, it should work. So if we do hello world.tasm, hello world.10, and it works. Okay, so that is perfect. So 0 will probably, let's look at Linux syscalls. My mouse doesn't want to work. Chromium syscall table. So let's look at that and see what we've got here. We don't have to base it off of these. Write, I feel like should be though. And maybe, yeah. So perhaps I should use like an enumerator for it as well. Yeah. So 0 can be read and 2 can be open, and then the rest, I'm not gonna really care about that. Yeah, so tagging that's, but now you can see how easy it'll be to implement a new thing. This is the wrong one. So thing.c, that's what I meant. Yeah, so we have 2, so that'll, yeah, so read and then open, and then we'll just do case 3 is malloc. So native malloc, and then break that as well. Indent, and then case 4 can be native free machine and break. So basically, malloc, it'll just push the value of malloc onto the stack, and then free can just free the top of the stack, interpreted it as a pointer. So that's good. So maybe I'll change like the numbers around for it, but you get the idea. So if we make now, it's gonna be n native, just to keep track of where they are. So I should also put them in order when I make them, so I'll do that. So I can do native malloc, and basically all that we need to do is push machine and then whatever malloc. And so actually I guess we should probably pop in the stack, and then that'll be sort of the number of bytes that we do. So basically we can do malloc 1 times num of bytes, and so we'll just do int num of bytes equals pop machine dot as int, something like that. So actually this needs to be I did that wrong. Yeah, so native free. Oh yeah, I didn't actually define native free. So that is fairly similar, except we don't need the extra one. So this can just be free. We do actually need it because pointer pointer equals pop machine dot as pointer, and then we'll just call. We don't need to push anything. We just need to free, just like that. So now, yeah, I need to do something like that. Yeah, actually, this needs to go in here. I don't know why I did that. None of bytes. So let me get rid of that entirely. And what is this? Why do I have... yeah, I just messed up the parentheses on that. So expected word. Yeah, so I need to do this, basically cast it to a word. Like that. But we want it as pointer. So, let's see, how can we kind of do that? Basically, we can do, pointer equals malloc, 1 times num of bytes, like that. And then basically we can do, word pointer. Oh, well, that would. And okay, so now we test.tasm, and then we open test.tasm. Then we can do native 2 is what it was, right? No, it's 3 actually. Native 3. And then we can basically just print what's at the top of the stack. So test.tasm, test.tim, and stack underflow. So because we didn't actually push the value, so we'll just push 8. We'll allocate 8 bytes. And there we go. So that should be the pointer. Yeah, so then we can do stuff with it. But let's actually free it as well. So then native 2, and then there should be nothing at the top of the stack. It's actually 4, it is free. I didn't need to rebuild it, so I don't know why I did that. Test.tim, stack underflow, okay, so why is, oh yeah, because we tried to print. Yeah, alright, so I'm assuming that worked. Alright, so that's pretty cool. So then we can allocate memory and free it. We can write. So let me actually, yeah, let me get rid of that, and then I'll add it to the standard defs that we have. So let me remove test.tasm as well as test.tim. Close out of that. Whoops. Alright, cds and standard defs. So we can define at def, yeah, we'll just call it malloc, is native 3. That 3 is native 4. So that should work now, and now we have those keywords. So I feel like I should change kind of how strings are handled as well. Yeah, so I can push this though, actually. So get add get move right and implemented native function and move right to be a native function. It's a bit odd wording, but that's okay. So let's push that. And let's see. So, yep. All right. So that works. So let's think about how I would go about doing this. Yeah. So now we can allocate to the heap. So that is cool. And now, right now, the way it works is basically we pop off from the stack. Like basically when we push a string, we just push each individual character. So something like that. Stuff like that basically is pushed. I think that probably should just push the pointer. Yeah, push the pointer to the character. Yeah. So that is going to change how the parser works. In here, where is right? Actually, it's in native. We don't have, yeah, no, but in the type string. So string, we not handle that in here. Yeah. All right, I guess string. So we handle strings in here then. Yeah. So yeah, right here actually. I'm just blind. All right. So basically, instead of doing that, we could push it as a pointer. Yeah. So basically, let me kind of just comment this out, and then look at what it's doing and modify. So, instruction type is actually already set, so we don't need to set that, but we need to do instruction value dot as pointer, probably PTR instead, but whatever, equals head value dot text. Yeah, and then let's see actually what that does. So if I build this, unused variable I, yeah, I can give it I, or I'll comment it out at least, because I'm not set on this implementation. So let me make a new test.tasm. Actually, quit that. That's not what I wanted to do. But test.tasm. And we'll open it up. And yeah, okay, so push hello world. Yeah, so we push that, and then test.tasm. So now it's that. And let's actually then print what we have on the stack. So that is the pointer that we have. So then we can use that in there. So it's not, yeah. This is the wrong one. I wanted .c file. Why did all of these do that? Oh, it's because of the way I exited incorrectly before. That's okay. So basically, in the right, basically we can, instead of doing it like that, we can do register equals, basically change it to a character. And then we can do machine, let's see, what is the, do we want to pop? Yeah, we want to actually pop. Pop machine as pointer. As, yeah, pointer, like that. And now, build that, and I seem to have messed something up. Yeah, so I wanted to cast it to that, but it's going to be automatically done. So, TASM, test.pin. So let's actually try to do native 1. And let's see, we need to push the 14 and then push 1. Yeah, so if we run this again, Tim, and it doesn't do anything, so let's look at what that is. Segfault. Okay, so doesn't like that. Actually, I don't think we are popping it in the right order, are we? We have file script. Yeah, so that should actually be fine. So what if I make this a void one? And then let's build that. And let's actually print it like this. So yeah, we build that again. And then we'll run test in. Alright. It doesn't write. And what if we cast it to a character? So yeah, I meant to do S, not C. Alright, and it does that. So it doesn't want to do that. Alright, in here, as pointer, we can do that. And stir. What if we do that? I'm not sure if that's right. Stir. And then don't cast this. Yeah, so it's still segfault. So, so do we need to allocate it though, actually? Like, so it runs out of, goes out of bounds, or out of scope. So, all right. Let's see. So can we actually instruction value dot add state, something like that. Build this again with dot TASM. So it does print, no. Yeah, so it prints that. Da, da, da. Yeah, so it is printing that. So it's fine there. So can we actually print the list? So native 4 text is hello world, so it gets the whole text. Yeah, so that should be fine. Yeah, that appears to work. No, but we don't actually look at it after we generate the instructions. So can we actually, let's see. So when we are here, we have the push. Yeah, when we push it, let's actually print it there. So let's push. Let's print f machine instructions ip.value.add stir, something like that. That's not 10. Actually, yeah. That's not 10. Alright, I need to fix this. So let me just do something like that. Alright, it doesn't work. So it is not valid. So let's print that. Okay. So it's not a valid string there. Instruction value that equals malloc size of. Let me just do that. Stir like that. Change this. Just all right. Yeah, change that. So that doesn't work. So that is not what it is. So just a program size plus, and then we will printf the text. Yeah, so this in each program. So basically, program I dot instruction. Yeah, instructions I. Is that right? Yeah, dot as stir. Yeah, so that is, so actually we don't need that. Instruction dot inst, what's it called? Dot value. Dot value. There we go. Hasn't. So it, let's see. So it's segmentation faults when it's not properly, when it's not right. But let's see. So what is the other one that we have? We We have this whole thing. After that though, it stops working. But it looks like hello world is valid there. So if we count this out, it's not printing elsewhere, I don't believe. Yeah, so that is yeah, so actually we can just look at the first one. Because that's the one that we are looking at. So that is fine there. That actually works. We don't need that anymore. Yeah, so we have that. But then when we go into here, it is gone. Doesn't work. So that is... Well, let's actually do basically what we're doing here. We are basically just getting... we can do this. And we can do... Instead of I, we can just put 0. And we can see what it says. Alright, that doesn't work, because program, it is machine instruction. So now, that doesn't work. Okay, like that. That key. Now, so then the save file is up here, actually. Yeah, so it doesn't exist here anymore. It is not valid. So how do we extend the life of it? Because we don't free it. I don't think I free anything in here. Which maybe isn't a good idea, but it's when we're reading it from the file. So it can't actually save it there. So that's why we do actually have to store it on the stack like that. So push 13. Yeah, so that is, we need to do it the other way that we were doing it. And I think that is the way that we're gonna have to do it. Which that's okay. I was just testing this. Yeah, so let's go back to Kaizen.c because this is where we actually change this. Yes, we can get rid of this. And then back in here, get rid of that, and then we can actually get rid of that as well. And let's do this way again. Alright, so let's run .Kaizen. Stop him, and it works again. Okay. Yeah, so basically, what I think we can do though, like if we want to get the length, we can push the character like this, and then basically we can do something like get length, right? So jump to that. Jump to get length. And make like a label up here that is like or it could be anywhere actually. It could be down here. Get length. Well basically, it is just going to pop each one of the characters until the top one is equal to this one. And then it is going to basically iterate a number and then return that number. So that is something that we could do to get the length of a string. And then the length could be at the top, so you call that, and then you don't have to push the length like this. Basically, I think that's how it's going to have to work. So, I don't think we can actually compare characters like that, because in the compare equal, yeah, so it interprets it as a float and not a character. So we would have to do something different for that. Yeah, so yeah, well let's see. So what have we can now allocate let's see, we don't need to call this or that. Yeah, so that all should be working. .tasm, that's .tim, and let me actually, I didn't test the, build all of them, and then we'll run test/fib, make sure that works. Seems to still work, and label, and macro test.tim, and okay, it all looks like it is working still, so that is good. So what should I do at the moment now? So did I implement, this was before the mallet, yeah, so I think we can do that, but now we should be able to implement the stuff to work with files, because we can implement it as a native function, right? To open the file, we can write to it and then close the file. And we should be able to just read it. It would fill up the stack quite a bit though. Yeah, so that's something that we could do. So let's see actually. Right, okay, yeah, so I think I can make this though. So implemented native write, or native mallet, and native grid. Yeah, so now it's pretty easy to add new, like, operations. We could just use this entirely instead of the functions, but I'm not gonna do that. So, because it doesn't really make sense. This is for anything where we're interacting with the operating system. So read. Let's look at the read and see. So look at that. Yeah, this one. So I think file descriptor, the buffer, and then that. So if we, yeah, we could take the buffer from the stack, where if we just allocate it, using malloc, use that as the buffer. The file descriptor can be done in the same way as write. And then the size, so you do have to know the size. Or that's just the amount that you're writing. So let's actually, so I don't think that reads me, like, let's try that. So let's do, that'll be 2. Yeah, so native read machine. So let's just implement that here. So native read. And yeah, so file descriptor is pop, so that's the first one. The length, and then the buffer equals pop machine.as pointer. It's not that, it is pointer. And then we can do read that, and then that should do stuff. So now we don't need to do that. Native read. Okay, so let's do, so that is, get rid of that. We can do push 14. So yeah, 14, and then we'll do native, or we can do, yeah, we don't actually have those. So native 3, and then we can do native 2. So what do we need to push here? So we need the file descriptor, which can be 0, and then the length. So we'll push 14. Yeah, so let's see what happens. Did I mess anything up? Okay. Test.tim. And then, alright, so hello world. And yeah, so it doesn't print it out, but I think it worked. So it's hard to tell. Let's actually printf, let's see, let's actually just print. We do that, print. Because now that should be stored in the buffer. Do we want to pop the buffer though? Because I think we are doing that. We just want to peek it. Well, actually, we can just push the buffer then. So push buffer. Machine and buffer. Something like that. And I think we have to pass this to a word. Like that. Build.sh. And that doesn't work. Like that. Nope. Okay. Okay, so like that, test.hasm, test.pin, hello, and then it prints out H. So yeah, so that, it did actually allocate that. And now, let's give it a print, and let's just, yeah, let us, in free, we'll just print, this is just for testing purposes, pop machine.add tester. Yeah, so we'll do that, and then we'll temporarily not actually free. Yeah, and we'll just call native 4. So that doesn't work. Yeah, there is no as sir, it's as pointer. And we need to cast it. Yeah, not sir, it's character. Alright, so that's not Kaizen. That's that 10, hello, and then, alright, it doesn't work. Yeah, that's okay. So it doesn't like that. Okay, so we can do that. Alright, let me get rid of this. So let's actually, let's print it here. And then, test.tim, hello. And so we can print it out. Where is it? So the free actually Syscalls. It looks like. So use parameter. Yeah, alright, that's okay. We don't need to worry about that. Test.tim. Yeah, so it Syscalls when we try to free it. That's not good. That needs to be that actually. That, and it's still Syscalls. Yeah, so the pointer is, so when we push it, it is not the same, because we're actually creating a copy of it. Yeah. So can we make